Hi, I'm Shyamala Gauri, Assistant Professor in Rohini College of Engineering and Technology. Subject code CS3301. Subject name Data Structures. Unit 5 Searching, Sorting and Hashing Techniques. In this presentation, I'm going to explain the concept of extendable hashing. It is a dynamic hashing method. The terms in this hashing technique are directories. The directories store addresses of the buckets in pointers. An ID is assigned to each directory, which may change each time when directory expansion takes place. The buckets are used to hash the actual data. Global depth. It is associated with the directories. They denote the number of bits which are used by the hash function to categorize the keys. Global depth is equal to number of bits in directory ID. Local depth. It is same as that of global depth except for the fact that local depth is associated with the buckets and not the directories. Local depth in accordance with the global depth is used to decide the action that to be performed in case an overflow occurs. Local depth is always less than or equal to the global depth. Bucket splitting. When the number of elements in a bucket exceeds a particular size, then the bucket is split into two parts. Directory expansion. Directory expansion takes place when a bucket overflows. Directory expansion is performed when the local depth of the overflowing bucket is equal to the global depth. This slide shows the basic structure of extendable hashing. Here directories and buckets are connected. This slide shows the working structure of extendable hashing. First, the data has to be converted into its binary format, f of h, and it returns to the directory. Directory points to a bucket where the data traverses to the bucket. Bucket is a place where data is stored. Now let us consider an example of hashing the following elements: 16, 4, 6, 22, 24, 10, 31, 7, 9, 20. Bucket size, for example, assume 3. Hash function. Suppose the global depth is x, then the hash function returns x LSBs. First step, calculate the binary forms for the given numbers, that is from 16 to 22 in the given list. Here the binary formats are shown for the given elements. Initially, the global depth and local depth is always 1. Thus, the hashing frame look like the below structure. Initially, insert 16, the element 16. The LSB for 16 is 0. So, it is inserted to the bucket for the 0 from 0th directory to the 0th bucket. Next, insert the elements 4 and 6. So now the LSB is 0. So it can be inserted into the bucket where the element 16 is inserted. And next, insert 22. The binary form of 22 is 10110. Its LSB is 0. The bucket pointed by directory 0 is already full. Hence, overflow occurs. Since local depth is equal to global depth, the bucket splits and directory expansion takes place. Also, rehashing of numbers present in the overflowing bucket takes place after the split. And since the global depth is incremented by 1 now, the global depth is 2. Hence, 16, 4, 6, 22 are now rehashed with respect to 2 LSBs. After bucket split and directory expansion is shown below. Next, insert 31, 7, 9. For 31, 7 and 9, the LSBs are 11, so it is inserted in its appropriate places. Now insert 20. Insertion of data element 20. will again cause the overflow problem. Since the local depth of the bucket is equal to global depth, directory expansion takes place along with bucket splitting. Elements present in overflowing bucket are rehashed with the new global depth. Now the new hash table looks like the below one. Thank you.